Today our topic is single minute exchange of dies. This term was coined by Shigeo Shingo. This is a guy. So this guy changed the whole industry. He changed the whole game. Before that, the setup time was seen as necessary time, but he said it is not the value adding time. And this is a very famous book of him. A very good book. I would definitely recommend if you really want to go into detail of this topic and reduce your setup time. Single minute exchange of die. So it doesn't matter if your setup time is 4 hours or 2 hours 20 minutes. The aim of this method is to achieve the setup time in less than 10 minutes. So 9 minutes or the less, so that we achieve this in single digit. That's the name of this tool, single minute exchange of dies. In this series of setup time, we will be first seeing how we can use this method, what are the different steps. So we will be seeing the lean tool in 6 steps, and after that we will see the examples. First example would be how to implement, how to use SMED for reducing preventive maintenance time, and the second example would be how we can reduce the setup time on any normal semi-automatic or automatic machine. So let's go ahead. So single minute exchange of dies, as the name suggests, we are aiming to reduce our setup time to 9 minutes or less than 9 minutes. There are 6 main steps to do it. Very easy to follow, very simple. The step number 1 is to divide the whole setup time into 2 main categories. The first category is internal activities, second category is the external activities. All the activities which are done in the machine, or we have to stop the machine in order to perform them, are internal activities, and all the activities which we are performing when the machine is stopped but are outside the machine. We are filling the job order number in the batch book, we are entering the data in ERP system, we are counting the parts, we are transporting the part, everything else is considered to be the external activities. So once we have categorized all the setup activities into these 2 categories, the next step number 2 is to externalize all the external activities. For example, we are doing the entry in the ERP system. For that we don't need the machine. So why we should do the entries in the ERP system in the computer when the machine is being stopped? So we externalize it. So we do these entries when the machine is running with the next job order, for example. So step number 2 was to externalize all the activities either before the machine is being stopped and when the previous job order is running, or after the next job order has already been started on the machine after the setup. So through this, now the setup time is only comprised of internal activities. The next step would be step number 3 in SMED will be to externalize the internal activities. So it could be that during that machine setup time, we are replacing the bits of a milling cutter in the machine. So it is actually internal activity, and we are changing the bits and we are aligning the bits and doing all these things. But if we would have a spare head of milling chuck, in which when the machine is running with the previous job order, we are already setting up this new chuck or second chuck, and we are aligning all the bits and we are replacing all the bits, and as soon as the machine is stopped after finishing the previous job order, we are just replacing the whole milling head. So with that, we have externalized this inspection of the worn out bits and aligning them, screwing them and tightening them, everything we have externalized. So this is the aim of step number 3. Step number 4 is to focus on remaining internal activities. Now we have relatively shorter setup time, but we are aiming here to perform these internal activities as quicker as possible. So what we are doing here, maybe we have 5 screws to tighten. Maybe we need only 2 screws, so we do this design change. Maybe we don't need the screws at all. We are now in the current state, we are having few screws, and with the improvement in this step number 4, we will use the levers. So we need not to unscrew or screw or do anything, any activity like this. So we would easily save a lot of time. So this step involves making the internal activities as quicker as possible. The step number 5 is not about reducing the setup time itself, but it is about optimizing the external activities. For example, now the setup time has been reduced from 20 minutes to 10 minutes, for example, but now the worker is doing the external activities. It is taking him longer time, or it's taking him 10 minutes. And the whole aim of this step is to make the external activities quicker, so that we can use the operator for running the machine, more important value-adding activities, and not doing the setup time. So this could be if the operator was changing the bits and manually adjusting and aligning. If he would have a gauge or something, he could do the alignment and tightening of these bits on the chuck instead of 10 minutes, maybe in 2 minutes or 3 minutes. So this step aims to reduce the external activity, the effort for the external activity. The step number 6 is to eliminate the setup time completely. How this is possible that we eliminate a setup time completely? This requires design change. It could be that we have 2 customers and we are delivering 2 identical parts with a very little change. It could be a change in color, it could be one part has 2 holes, another part has 1 hole, or a very small design change. One part has two small inexpensive parts, and other customer is asking for only 1 small part on a big assembly. And we are, for example, we are delivering these products which our customer further is assembling into a big assembly. So it means it will not affect the appearance for the end customer. In that case, we can talk to our customers and ask them if it will make any difference if we will modify their product a little bit. For example, we will deliver the same part with 2 holes to both the customers, or for one customer it doesn't matter if the color is brown or it is black. In my practical experience, we were delivering 2 assemblies there, and the difference was, to one customer we are delivering with 2 components, and another customer we are delivering with only 1 component. So we asked the customer who was receiving with 1 component if his functionality will be affected if we deliver with the 2 small components. And after discussion, we knew that for him it doesn't matter. So for us, we just had 1 standardized process for 1 assembly with these 2 small inexpensive parts, which in the end the increase of cost was just few cents, but it saved a lot of management effort, a lot of effort to maintain different articles, different inventory, and we could reduce a lot of buffer area for implementation of our Kanban system. So all these benefits. So these were the main 6 steps which you could use to reduce any setup time, and not only the setup time but also for optimizing and reducing the downtime in many other categories. As previously mentioned, preventive maintenance, it could be R&D trial time, it could be the plant weekly cleaning. These are all the categories you could optimize easily with these 6 steps. There is a common myth that SMED, single minute exchange of dies, is a tool only to reduce setup time. But this is not correct. On your bottleneck process, you will see in OA data that there are different type of downtime categories you have, and the time lost in these categories can be easily optimized by a single minute exchange of dies. For example, in your OA categories, there could be time lost through preventive maintenance. It could be that we are spending some time, or we are losing a lot of time. Research and development trials are being done on the bottleneck process or the other machines. and we have regular cleanings, and obviously for the setup time. This is a so simple and easy tool, yet a lot of people are thinking that it is only for optimizing the setup time. No, there are many categories. In this series of setup time, we will be first seeing how we can use this method, what are the different steps. So we will be seeing this lean tool in 6 steps, and after that we will see the examples. First example would be how to implement, how to use SMED for reducing preventive maintenance time, and the second example would be how we can reduce the setup time on any normal semi-automatic or automatic machine. What are the benefits of single minute exchange of dies? This method, when we apply the first time, normally it achieves 50% reduction in setup time. So imagine if you have reduced the setup time to 50%, you have this time, instead of doing the setup on the machine, we can produce more parts in this time. That is how we can increase the productivity, because if we have applied this method on a bottleneck process and we are producing more parts, so with the same number of workers on the machine in the production line, we are producing more parts. So this will increase the productivity of our line. The second benefit of reducing setup time is the flexibility. How we can achieve the flexibility? Imagine we have reduced 50% setup time. Now we can also reduce 50% our lot size. So it means we will have the same effort, same amount of time to do setup time, but we can double the number of lots because our lot size is reduced. Imagine earlier we were producing 100 parts in a lot, but now we have reduced the setup time 50%. Now we can produce a lot size of 50 parts, and we will not decrease the productivity, we will not decrease the output, but we will produce, instead of 10 parts, 10 lots per day, we can produce 20 lots per day. What will happen with that? If we were producing earlier, imagine 10 articles in a day, and our dispatch department could deliver to the 10 different customers. Now, because we can produce in smaller lot sizes, we can produce 20 different articles, and our dispatch department can serve much more customers, maybe 15 more customers in total, or 20 customers, because every day we are producing small lots but a good mix of different parts. This is how we can serve our customers, different customers, in much shorter period of time, which is an enormous advantage in today's world. The third benefit is the cost. If we have reduced, for example, 50% of our setup time, in this saved time we can produce more parts. So all the number of people in the line, all are the same, we are producing more parts. So we have reduced our direct and indirect costs there. The other way, if we, instead this saved setup time, we are using to reduce the lot size, with that we are bounding 50% less parts in the production. Earlier there was a lot of 100 parts going through the production. Now there are 50 parts going through the production. So it means the bound capital in the production for that size is now 50%. We need 50% less parts to start the machine. That means the inventory, the raw material inventory from our suppliers, we can reduce maybe to 50%. And also the finished goods inventory, we can also reduce to 50% because the lot size is now smaller. We can have a variety of different lots, but we can also reduce the inventory. Earlier, 10 batches would have 1,000 pieces. Now 10 batches would have only 500 pieces. With that, the cash flow of the company will improve, and the bound capital in the whole production will be 50% less. The fourth benefit of reducing the setup time is the quality. We have seen if we reduce the setup time, we can reduce the lot size. So imagine again we were producing 100 parts and sending this lot size of 100 parts to our customer process, and there it could detect any non-conformity, any quality defect or anything. With that, all the 100 parts, the probability is very high that all the 100 parts are affected with this defect. Now with the setup time reduction, if we reduce the lot size to 50% and we are leaving our customer process in much smaller sizes, now if customer process detects any defect in the part, definitely maximum affected parts will be 50 and not 100. So the smaller the lot size we have, the quicker feedback from the customer process we will get in the previous process that my parts are good or I have any defect or anything. This feedback loop from customer process to the supplier process will be 50% quicker. Therefore, the number of parts affected by quality defects will also be 50% less. The last benefit we have here on the list is the leveling. So we have reduced the lot size. The different parts in the production might have different bottleneck processes. Part A might be a bottleneck process on process 1, but the type 2 part might be the bottleneck process on process number 2. So if we have the larger lot sizes in the production, our one process number 1 for example, might be a bottleneck process for longer period of time, and the supplier process of this process or the customer process of this process might run out of buffer, might run out of the parts to produce. So, and that lost time can never be recovered. But on the other hand, if we have smaller lot sizes, so therefore the bottleneck process will switch in the production from process 1 to process 2 very quickly. And with that, the supplier and the customer processes might use their buffer in that time. So with that, there are more chances that supplier and the customer process are not running out of stock and they can produce continuously. So that is also a very big benefit which is hidden, which is not very easy to recognize, which is delivered by the shorter lot sizes in the production. Previously, we have seen how to use this lean tool in 6 simple steps. And let's see how we can use the SMED method to reduce the time for preventive maintenance. Let's see an example of heating furnace in which we are performing preventive maintenance once per week, and it's taking more than 5 hours every week. And let's see how this method can help us to reduce the overall maintenance time there. The very first step is to record all the activities being performed during this preventive maintenance. So there are 2 methods. First is that we go in the production and we note down all the activities being done. The second method is to do the video recording, which makes every process, which makes every step in this analysis very easy and very effective. So wherever it is possible, wherever it is allowed by the company and the management, we must try to do as much as possible the video recording, because that helps enormously later on to discuss with the whole team, to show the video and to ask the questions how we can externalize this activity, how we can do this much more quicker. Whole analysis become much more easier through the video recording if it is allowed. So in this our example, we went in the production when the preventive maintenance was being performed, and we did the video recording of the main activities, and we have here a list of 12 activities. And so with this we have the column from to the start time of an activities and end time of the activities, and after that in the last column we have here the total time spent. For example, the activity number 2, it took us 1 hour, activity number 3 took 20 minutes. So this is the beginning of the analysis. Let's go through very quickly these 12 main activities. The furnace is being stopped, the activity number 1. Activity number 2, we are waiting the oil of the furnace to be cooled down so that it comes to the room temperature. Activity number 3 is then the maintenance guy is collecting the activity number 4 is that we are pumping out this tempering oil out of the furnace. Activity number 5 is we are filtering that oil. Activity number 6 is that we clean the filters and we inspect the moving parts for any wear and tear. The activity number 7 is that we are cleaning the furnace tab. Activity 8, we fill that filtered oil back into the furnace. Activity 9, we heat up the oil again. Activity 10, we produce the first 10 parts. Activity 11 is we bring these parts to the quality department and wait for the results. And once this is okay from quality side, they say we can run the machine. Then activity number 12 is that we start the machine. If we now apply our SMED method, which we have previously discussed, the first step would be to clearly define which activity is external activity and which activity is the internal activities. So here we see the activity number 3 as well as the activity number 11 are the external activities. In step number 2, we are aiming to externalize all the external activities. So we see here, we have here activity number 3, in which the maintenance guy is bringing all his equipment, pump, container, etc. Altogether, it is taking us 20 minutes to perform that, and he can do that, and he can do this before the machine has been stopped or during the activity number 2 when the machine is being cooled down. Similarly, the activity number 11 is that we are waiting for the quality department to give us the results, and instead of waiting during the activity number 10, we can take the 10 parts out for the inspection, and after that we can start the machine immediately. For this, we really have to do the risk analysis. How often we have seen in last 1 year that the first 10 produced parts were defective. If that has happened, say 2 times in the whole year, so if we run the machine for this 25 minutes, how many parts we will be producing? Imagine we are producing 25 parts here. So if this has happened 2 times in previous year, so it means we could have wasted here 50 parts. The cost of 50 parts we should compare with the cost of the not running machine for 25 minutes every single week in the whole year. So with this argument, in my experience, all the time I have done this analysis, the cost of stopping the machine was always much more higher than in case we have the quality issue and we have to scrap these parts few times per year. So with that, we can keep the machine running and do the inspection when the machine is running there. After that, the step number 3, we have seen that it is to convert the internal activities into external activities. So here we can see the activity number 6 was to clean the filter and check the moving parts for wear and tear. So how we can externalize? So instead of cleaning these filters when the machine is being stopped, we can simply replace these filters with already clean filters, another set of filters we can simply replace. So we will be much more quicker, and the cleaning of the filters can be done offline when the machine is running. Another activities we are performing here is we are checking the moving parts. So we are unscrewing the cover, metallic cover here, and then we are checking if the parts are okay, and then we are screwing again the cover. So we can ask the team how we can externalize, how we can do this activity quicker. One example could be that we would have a transparent cover in which we need not to unscrew the parts, and we can just see anytime that the moving parts are in good shape. We have externalized this activity completely because we need not to stop the machine for doing this activity. So by doing this we can save our time. For example, activity number 6 took us before 20 minutes. Now we can replace the filters, and inspection we can do any time of the moving parts. So we have finished this activity in just 5 minutes. Step number 5 is to improve the internal activities or to eliminate them completely. Here the activity number 2 is to cool down the furnace oil. It is taking 1 hour. So if we use an external equipment for cooling, we can accelerate the cooling here and we can reduce the time. The activity number 4 is pumping out the tempering oil out of the furnace. So here, if we have seen that it is taking us approximately 40 minutes. So instead of pumping out the oil with one filter, we can ask if we want to make it quicker, how we can do it. Maybe we can use 2 pumps instead of 1 pump, and we will reduce the pumping time by 50 minutes. Or we can use one bigger pump, which is much more quicker. The activity number 5 is to filtering the furnace oil. So here we are taking the oil out, bringing the oil to filtering unit, and after that we are filtering there separately. One option could be that when we were previously pumping out the oil, during that process we can have the filtration unit mounted on the pump. So during we are taking the oil out of the machine, the filtration is also happening simultaneously at the same time. So with that we can eliminate the filtering time completely. Activity number 7 is that we are cleaning the tub. During the preventive maintenance, it was being done manually. One person was manually doing the whole cleaning and everything. We can ask how we can do this cleaning in much shorter time. One idea would be that we use the equipment. For example, we can use the water jet or any other equipment which is cleaning it everything in much shorter time. Another idea would be that instead of one operator, there are 2 operators who are doing all the activities. For example, one operator would be the machine operator, and another worker would be from the maintenance department. So the whole maintenance, including this cleaning, can be done by 2 workers instead of 1 worker. So with this arrangement, we are also shortening a lot of maintenance and downtime of the machine. The activity number 9 is again heating up. Similarly, as we have cooled down our oil with the help of external unit to reduce the time, in the same way we can use an external unit to heat up the temperature so that we are bringing it to working temperature, the oil, in much more shorter time. So here we see with that we can further reduce the time required for these internal activities. So here we can see that we have reduced the time here by 40% as compared to the time it was in step number 3. We know the step number 5 was to improve the external activities. We see the example number 3, bringing the maintenance equipment, tool and pump, in which the maintenance guy was collecting all the things. So if he's doing it offline now, but still he's spending 20 minutes to collect all the things from different corners and everything. But if we would have one maintenance trolley for this maintenance particularly, he need not to collect from different areas and different equipments, but he would have always one trolley ready where everything is there and he's just bringing. So he can save his time also for collecting different equipment from different areas. Similarly, the activity number 11. Though we have externalized this activity, now this is done when the machine is running, but still the time spent by our operator is still the 25 minutes. We can reduce his effort, which is the aim of this step to improve the external activity, if we train the worker to do the whole inspection, so that we need not to go far away to the quality department, wait for the result and then go back again there and bring the parts back. We can eliminate all these things if we train him, and if we place the equipment for the measurement or microscope near the furnace, so that he need not to go there. He has the training, he fills the form, protocol, everything, whatever the quality department is doing, he can do that himself. This is how we can reduce his work. In SMED method, we know during this step number 6, we eliminate the setup time through the design change. In this example, we have used the SMED method for preventive maintenance. So here this means that how we can reduce the frequency of the preventive maintenance. We are doing at the moment after every week, because the oil is being dirty, the cables are breaking, and we have wear and tear of the moving parts, and we need to do that every week. Instead of doing it every week, in this step number 6, we can ask what we can change, what design changes we can do, that we don't have to do the preventive maintenance after 1 week, but maybe in 2 weeks or maybe in 3 weeks. For example, we know that we have to do the preventive maintenance because the oil gets dirty after 1 week. But if we could do pre-wash of the parts with any inexpensive process, we can very easily increase the time the oil gets dirty. And we can also use a better filtration method, maybe better filters or other filtration unit, that the oil gets purified and it can stay in good condition for more than 1 week, for 1.5 weeks or 2 weeks. And also we can check for a better quality of oil. If we know that every week we have to do the preventive maintenance because the cables are getting broken, we can ask if we have alternative supplier of cables. And the mechanical parts which are getting damaged, we can check if we can have better quality of the parts. So with all these things, if we discuss in the team, we can definitely come up with the ideas that we can reduce the frequency of preventive maintenance. In the end here, we can see the result that in every step we could reduce the preventive maintenance time. For example, in step 2, we could reduce 13%. Step number 3, we could reduce 4% further. In step number 4, we have further reduced the preventive maintenance time 40%. In step number 6, we can reduce this to 11%. So in total, we could reduce the preventive maintenance time by approximately 70% here. So we have seen here that the SMED method is not limited to only setup time optimization. With this example, we have seen that we can optimize the preventive maintenance. We have got the similar result. We have reduced the preventive maintenance time by 70%, which is a very good result in the first implementation. And after a few months, you can again repeat the SMED method and we can further optimize this process. Let's see another example, how to reduce the setup time on a very normal semi-automatic machine or an automatic machine also. So in the previous example, we have seen how we can use SMED method to reduce the preventive maintenance time. In this example, we are using the SMED method for setup reduction. All the activities in the setup are not very special activities which are performed only on this machine. I'm pretty sure that some of the activities or most of the activities which we are going to see or we are going to optimize through this method can be used by you on your machine, can be optimized based upon how we are going to think in this example. So in this example, we have taken one automatic machine and we have here recorded the setup time. As previously mentioned, I always recommend wherever possible to do a video recording of the setup time, so that later on we can discuss with the team, we can go through some activities again and again and we can discuss. It's really much more beneficial. In this particular example, we have here in total 10 activities. First column we have all the activities and after that we have the time from to, so the starting time for a particular activities and the finishing time of that particular activity. And in the last column we have here the total time required for that activity. So here we start. Let's go through all the main activities which are being performed during the setup. First of all, the activity number 1 is that we empty the machine so that the last part of the last order is out and the whole machine is empty. After that, the machine operator is counting the quantity of the good parts and he's counting the scrap and he's filling the paper. The job order in ERP is going to the computer and registering the finished job order there. Activity number 3 is transporting this finished job order to the next process. Then he's going to the storage area and to the previous process and bringing the material for his next job order. And then he's again going for collecting the tools, jigs, fixtures and other parts which he requires for the setting. And then he comes back to the machine with these parts. And then activity number 6 is that he's actually changing jigs, parts, or the other plates there. The activity number 7 is that after setting up, then he's starting the job order. He's feeding the material, the new job order, and he's starting the machine. And activity number 8 is that after production of first part, he's stopping the machine. Activity number 9 is going to the microscope. He's checking the part visually if everything is okay, and he's checking the main dimensions of that part. And if everything is okay, the last activity is that he starts the machine. So these are the main activities which are very common in most of the automatic machines. And here with this example, we can see what are the ideas and how we can implement SMED method. The very first step is to categorize activities into internal activities and external activities. Here we have a very good mix of internal activities and a lot of external activities. The step number 2 is to externalize all the external activities. The activity number 2 is count the quantity and the scrap and fill the papers and do the entry in the ERP system. This can easily be done after starting the machine with new job. So this is an organizational issue. Through the training to the operator, this can be easily managed. Then we have the activity number 3, transport the parts to next process. So it means after finishing the previous job order, the operator was transporting, but this can be done after starting the new job order. Activity number 4 is bringing the parts and the material for the new job order. Actually, this can very easily be done before the machine was stopped, before the machine has finished the running job order. So operator could have easily prepared everything, and when the machine is stopped and has finished the running job order, then he or she could have started with the setup time and not then going to the previous process or to the storage and bring the parts. Activity 5 is to collect jigs, fixtures and the other parts. This is also in a similar way as the activity number 4 that could have been prepared before the machine has finished with the running job order. Similarly, the activity number 9 is going to microscope and performing the visual inspection, checking the dimensions. And this is the external activity. This we can easily externalize, that we perform this activity when the machine is running. So here we might have to talk with the quality department, and we have to show the risk analysis, that how many times in previous years or in last year this has happened that the first few parts were defective. Currently we are stopping the machine for this activity so that we don't produce scrap. But if the total scrap cost in previous 1 year is lower as compared to the cost of not running the machine, then we can easily convince the quality department and the management that we want to go with risk, because we are finishing this activity anyways within 3 minutes and we are coming back onto the machine, and we can stop the machine in case during the inspection we know the parts are not passing the inspection. So with that way we can externalize this activity and let the machine run, and we can reduce the total setup time here, because all the external activities mentioned here are not done when the machine is being stopped, but are done either before the running batch is finished or after the new job order has been already started. So in this example we have reduced approximately 51% of the setup time just by externalizing the external activities. The step number 3 is to convert the internal activities to external activities. We have here the activity number 6, in which we are really doing some setup. We are changing the jig, we are changing some plates, we might be changing some bits, we might be changing different parts. And the improvement potential is here that instead of changing small parts in the head, we just change the whole head. Let's see an example for the milling cutters. It might happen that after a job order is finished, we check which bits are worn out, we have to replace, we change few worn out chips and we align them, we put the new one and we tighten them. Similarly, it could happen for the turning tool also. That on lathe machine, we have seen, okay, the bit of the turning tool is now gone and we have to replace it with the new bit. This takes a lot of time. Instead, what we can do, we can prepare another head, another turning tool, another milling tool, which is already ready, and as soon as the job order is finished, we just replace the whole head with the new already prepared inspector head, and we are finished. We are very quick with the change. Now we can say that, okay, all of us are not dealing with these simple heads, turning or lathe machines. I have seen this idea applies to most of the special purpose machines. It doesn't matter what type of machine we have. Most of the time that we are spending a lot of time replacing one small tool or some wires or anything on that particular head. In case we take the complete head out and replace it with the new head, which is anyway in the company as a spare part available, then we are much quicker, and we have offline a lot of time to check, inspect and do a very good quality setting, and the machine downtime for doing this activity can be drastically. Similarly, there could be during the setup time, we could be changing some plates, and in traditional way there are a lot of screws, bolts, nuts we have to open, and we can question when we are doing SMED analysis. If there are, for example, 9 bolts, then we can ask, do we need 9 bolts here, or we can just have 4 bolts and they will function the same. Similarly, we can also ask if we need to have bolts at all, because to screw and unscrew a bolt we need spanner also. But instead of that, we can have one wing nut in which we don't need any tool. An operator can simply with hand can rotate and open or tighten the screws. Other ideas during the setup time you can think of is how the fastening or tightening of the screw is happening. For example, in traditional way, we are opening the whole screw. A screw might have, say, 28 threads. So in order to remove a particular plate or a part for the setup time, we might have to rotate a screw 28 times and then remove the screw, and then we can take. This is 28 threads per screw. If we have more screws, then even it's more time consuming. In a more lean way, you can have pear-shaped holes in which you just have to open one thread of a screw. After turning one time, the plate will be loose, and then you can slide it in one direction and you can easily remove a plate or any part. So it's one thread loosening system here. Or there is another idea in similar cases that you can have C-slots instead of traditional holes, in which you just unscrew one thread of the screw, and after that you can just slide and remove the part. So these are the ways in which you can speed up the whole replacement of the parts during the setup time. So in case the setup time involves any fastening or any clamps with bolts which requires spanner or other tools, that you can also check. There are in the market a variety of clamps which don't need any type of spanner, Allen key or anything like that. They can be just simply with hand, can be clamped and can be very easily opened, and that eliminate the whole work of loosening, removing the packing plates and replacing the packing plates as per the height of the parts. Everything is eliminated if we have this state-of-the-art clamps which are very easily available in the market. So here in our example, we have seen for the activity number 6, we have a lot of ideas, and depending upon our machine, our setup, we can use some of these ideas or other ideas, and we can speed up this change process. In our example, we have seen we want to change the whole head, and then we have reduced here the time for this activity from 7 minutes to 2 minutes. The step number 4 is to improve the internal activities or eliminate that. So in our example, the activity number 1 is to make the machine empty, and also the activity number 9 is then again fill the machine. This is a very common practice that when a job order is finished, we are emptying the whole machine, and that takes some time depending upon how long the line is or how long the machine is. And after that, when we start the new job order, the same time is required. The main reason behind that is we want to be sure that we don't mix the parts from last order with the next job order. So in order to avoid that, we are wasting our production time just to run the machine empty. So this can be avoided, and after finishing the one job order, before starting the another job order, we can put dummy parts in between them, maybe one part or few parts. The dummy parts which are either different in shape or they are very different in size, so that in the end when they reach to the last station, the worker can easily distinguish that here is the end of last job order and the start of the new job order. And then he can stop the machine and he can change the containers and everything without losing this 20 minutes to make the empty, 20 minutes to refill the machine. So we can save 40 minutes very easily. In case we cannot rely on the operator, we can also think of if we have any limit switch or any sensor which can sense that my dummy parts are different in shape or different in color, and as soon as these parts reach to the end, the sensor or the limit switch will be triggered and the machine will be stopped, and the operator goes and separate the job orders, and after that run, and we save a lot of time with that. So in our example with a relatively smaller line, we have saved here 3 minutes, because earlier for making the machine empty and filling was 5 minutes for each activity, and now we can finish the whole process in less than 3 minutes, in 2 minutes. Step number 5 is to improve the external activity. So we are not reducing the setup time, but we are trying to reduce the non-value adding activities, or we are trying to reduce the waste in the production and save the time of the operator. The activity number 2 is to count the quantity, to print out papers and then fill the papers, and then going to the computer and doing the entries in the ERP system. And for that, one idea would be to check the layout plan if there is any potential for improvement. Maybe in the current state the operator has to go to computer, take the material, tools, and to the printer, and all that they are not in a right sequence, or they are not in the optimized layout. And if we optimize the layout, maybe it's very easier for operator to do very quickly and move from one station to another and save a lot of time. Another ideas could be that we use barcodes. A lot of time I have seen that the operators are really writing on the paper the numbers, the quantity, the operator number they are writing, the machine number they are writing, which can very easily be scanned with barcodes. For example, every machine has its barcode. When the job order is finished, the operator is just scanning the barcode of that particular machine and done. So there are many ways to optimize all the activities. Next activity is the activity number 3, in which the parts, the finished job order is being transported to the next process. So this is taking some time. Here we can brainstorm with the team that how we can make it quicker, more easier. Do we need the adjustable trolleys? Will that help in this particular case? Or can we have some conveyor belts so that the operator doesn't have to go from one process to the another process every time when the job order is finished? With a simple conveyor belt, he can place the parts on the conveyor belt and simply press the button, and parts will be transported to the next process. The activity number 4 we have here: bring the parts and the material for new job order from the storage area or from the previous process. So in this case, what we can do is that we use our skilled operator only for the machine, and for such activities, transporting the parts to the next process or bringing the parts from previous process and the material to the machine, that can be left to unskilled operators whose job is just to go through all the processes and see if there is need for any raw material or the parts, and then they are continuously transport. Benefit of this would be that normally the skilled operators on the machine, they are expensive and they should not do the unskilled activities like transporting the parts and everything. So we save the time and we save the cost for the company by implementing such actions there. Also, we can check if there is really a need to go far away to bring the raw material, or some of the raw materials can be stored directly near the machine or on the machine, that after a job order is finished, the operator or logistician must not go too far away and bring the parts from there, if that could be stored near the line. The activity number 5 is to collect the jigs, fixtures or other tools for the setup time. Typically, this can be optimized by setup trolley. I have seen mostly in one process where you have 4 to 7 or 8 machines, we need 1 to 2 setup trolleys, and whenever this next setup is, the operators are bringing the trolley where all the tools, all the parts are available. No need to search anything, and through the visualization of these trolleys, it is clear if there is any important part, spanner, plier or anything is missing, that can be seen before the machine is stopped, and then it can be placed again back into the trolley. And when we start with the setup, everything is there, and the trolley sometimes serves as the checklist also, in this case, that you haven't forgotten anything, and then we save a lot of time of searching different tools. The activity number 9 is another external activities which can be easily optimized. In this example, we have seen that we are going to microscope, we are checking the dimensions there, which can be easily optimized. The visual inspection is mostly unreliable. We have to do MSA every year and we have to train the worker in the production, and still we have a lot of manual error. So this can be optimized by automatic optical inspection. If we have down the line manual inspection process, then it makes sense to have AOI, so that down the line we don't have to do any additional inspection. We save the cost, because normally the AOIs are expensive. But in case we don't have any manual inspection down the processes, in that case, only to the setup time quicker, we cannot buy AOI. In that case, we can think of any small camera system. There are plenty of cameras available in the market, and we can install that camera in the machine, which can detect most of the errors in the part, not all. And in that case, we can avoid during the setup time that we have to stop the machine, we have to take the part out, we have to do the inspection, and if the parts are okay, then we have to run the machine. So that can be seen, and easily if we have a simple solution for just one camera, that should not be expensive than the time we are spending or we are losing by stopping the machine. And by calculating the return on investment, you can decide if we can install a small camera system or not. Another activity is here done is that we are doing the dimension checking, which might be done with vernier caliper or other methods. It can be done, and at every cost that must be avoided, that operator has to set, he has to use an equipment like vernier caliper, check it. It's more time consuming. So instead, we have in the market a lot of gauges, no-go gauges, pin gauges. We have a lot of variety of gauges, which makes this process very quicker. So the operator doesn't have to see or has to read the reading also. What is the reading on my measuring equipment? An operator can just simply with the gauge can check if the part is going in this gauge and not going in, if this is right or wrong. Very quick and very, very reliable method. Last but not least, we have the step number 6, and in this step we aim for completely eliminating the need of setup at all. So in this step we are asking the team members, or research and development also is included here, to go for the design changes, that if we have 2-3 different articles, that can we reduce the number of articles with that. In this our example, we were supplying to a few customers where on the same product only the number of pins were different. Some were having 2 pins, another were having 5 pins, another were having 10 pins, and with the simple change in design. And after talking to the customer, the result was that few customers did not have any problem if we supply them the parts with more pins. The cost of per pin was very less, but it reduced the number of articles in the production, so we need not to do very frequent setup change. And also in our ERP system we have to maintain less number of articles in this case, so reduced. So we have, instead of 10 recipes, we will have 5 recipes. So if there is any change in the parameter, number of articles, and if we reduce the number of articles, the recipes in the machines we have, that will also enormously benefit the production. So in the end, we can see here the results. After applying this SMED method, we have seen that we could reduce the total setup time approximately by 80%. So, and this was the first time implementation. You can apply this method 2 or 3 times again after a few months, and you can really harness the benefit of using this very effective yet simple lean tool. Here in this example, we have seen that we could reduce the setup time from 36 minutes to 8 minutes. In your case, if it is not that much reduction, but still there is a huge potential. If we use this tool, in normal cases 50% of the reduction in setup time is very common when we apply this method first time. If you have liked this information and the videos in this series of single minute exchange of dies, last request from my side, just don't leave this information here. After watching this, go in the production area and look out for your bottleneck process. On the bottleneck process, see how much is the setup time through your OA data. In case the time wasted for the setup time is more than 3% or 4%, definitely there is room for improvement, and you go and apply SMED method as we have discussed here in these videos. And after that, don't forget to calculate the benefits, either the output in euro or reduction of inventory or reduction of lead time, all the benefits what we have discussed previously. Don't forget to mention that, to calculate them, and if possible, calculate them dollars or euros. And after that, you can show these results, especially in dollars or euros, to your management, and let your team shine through your results. And then you will get more resources and more focus for similar future projects, and that will benefit your team and your company enormously, because this tool is very simple but very effective to improve the productivity, to reduce the cost, and to have an enormous competitive advantage. Thank you.